You said you start with a goal, right? A problem that you're looking to solve, and you hunt around for potential kind of candidate approaches. Um, Give us a flavor for how that kicks off in the organization.
Let's do this in role playing.
Okay.
You're a manufacturer of some electronic component. What do you want? What's your problem, Azeem? What would you like?
I would like a flexible display for my self-driving car. I like the Jetson bubble cars, and so we want to put a Jetson bubble car. It's like a hemisphere, but we want the whole of the interior to be a display, and we want to be able to control the opacity for privacy.
So what that means is you need something that's flexible. You need something that's hard enough that that you can have it. You can print certain kinds of circuits on it, but takes kind of nanowire circuitry, so it's functionally clear. And you need something that glues well because you're going to want to probably put a coating on the outside that's really quite hard, right? So what that means, and for you chemists out there, I'm going to botch this so you'll get a sense. So I would go through and I would have a material scientist who would describe the chemical motifs that would allow that performance. So a benzene ring at the center and electron sparse linkers for transparency and some nice handles that work for adhesion or something like that. Then what you do is you come back, and that at the moment at least is a somewhat human mediated task. So what you do is you come back to our facility. We've built a set of software that allows us to predict all of the molecules that you can make inside a cell and is searchable by both these motifs and as well as certain machine learning driven predictions of material performance. So they would come in and they would take those motifs they did, you would search for it, you would put an additional set of things in, molecular weight no larger than X so that it's easy to polymerize. You would have, flip on the machine learning toggles that said, I want to have electric conductance that looks like this and this and this, right, et cetera. And it would pop out of our system 50 to 100 novel monomers.
Right.
So
People who are not au fait with their chemistry as a sort of a molecule that can be strung together to create a polymer that will be a.
It's think of it as like a very simple Lego brick, chemical Lego brick. And this is going to come up with a bunch of things that are quite different than you would be able to get, and we know this empirically, will be very, very different than what you would get from a petrochemical process, or if you looked in the Sigma Aldrich catalog, which is kind of the standard researchers kind of catalog of novel chemicals to play with. Mm-hmm. And so you start with this kind of sense of, wow, these are pretty interesting. So the next thing we do, I want to pause there. Does that make sense, Azeem? You with me so far?
Sense is great. Yeah, you've done what I understand is you've identified the characteristics you need. You've had a chemist turn those into sort of specific molecular signatures. You've got a database of things that map those signatures. You've tried to map them, match them.
The database is a little bit more complicated than the database. The database is actually a set of predictive algorithms with known enzymatic function that allows us to predict what you can make inside a cell.
Okay.
So it's not a conventionally gathered database. And we're on, I don't know, version 6.1 of it today. So every time we learn about new enzymatic function, we update these predictive algorithms. So it's a database, but it's a database that sits at the end of a set of predictive algorithms. Right.
Perfect.
And then we do a couple of things. Then we will, in effect, what you do is that same predictive algorithm tells me the genes that will make it. Right? It'll tell me the 4, 6, 8, 15 genes that will make it. Mm-hmm. And we take that as a foundation, and then we have another set of algorithms that are linked to now a database we do have of about 220 million proprietary genes, and we'll create a whole wide variety, call it 1,000 variants of that initial design.
Right.
And if it's, imagine if it were just a one gene pathway, it won't be, but you'd literally just have 1,000 variations, 1,000 different genes that are similar to the core gene, but not exactly the same.
But choosing those 1,000 out of 220 million must be a task that is mediated by some piece of software.
It is exactly, I mean, this is what machine learning is for, right? And to be clear, you're looking for homologs. So all 220 million are not a homolog for, it's not 220 million choices for each gene, but still that the process of designing the best 1,000 is very much an algorithmic process, right? Once we've got those 1,000, it goes into a different set of software where robots will then, as we talked about earlier, put those pathways, put those genetic constructs into existing strains. And we'll typically do 2 to 4 types of microbes, right? Because we're not exactly sure which one's gonna be best. And you start to manufacture. You'll get trace amounts, or not trace amounts. You get small amounts of the molecules of interest. At which point you start then testing them against your material needs. So you start to say, aha, I wanted that Jetson bubble car, right? Now I have to make the film with this molecule and see if it achieves the product specs you're talking about. That also is a thing that's done by robots, because we like robots. And there's this back and forth where you're kind of testing the formulation of the material. The molecule is not the same as the material, right? The molecule confers the performance properties of the material. The material is still it's a recipe, right? And so you're tweaking the recipe. And once you get a final recipe, you go back to the microbe and you make a series of genetic changes to it to persuade it to make it at lower cost, higher productivity, whatever.
So you're getting me to the stage where I'm getting my film for my bubble car, which is great. I will be a happy customer, I can tell.